Good morning, everyone. I will tell you about a little survey we undertook last year. It was done at the Center of Research of Aragon under the Unit of Forest Resources and within the Forest Ecophysiology Lab. Forest Ecophysiology Lab. Some overview of the work we are undertaking. We devote ourselves to the study of adaptations to Mediterranean climates. This climate is peculiar, is very particular. We study the effects of global change on plants, such as forest decline. We also study the nature of the leaf from different points of view, from the photosynthesis, defense, water status, mechanical properties, longevity, and moreover, there are 3 studies focused on oak, pine, and ibis. We devote this study on these 3 species because they can give birth to huge forest mass with the atmospheres. For any activity that we do in the atmosphere is in contact with our skin, but we breathe in this atmosphere and we introduce it within our bodies. These atmospheres, one of the major components of the forest atmosphere, the terpenes. These are molecules apart from other plants. They are produced basically by conifers. Plants use and produce them as a protection against larvae, insects, or other species. Some of these terpenes are spread to the atmosphere. They are volatile, the volatile terpenes. Some surveys considered some benefits of these terpenes on human health, such as anti-inflammatory or antioxidation properties. We think it is worthy to measure the terpenes concentration, and we have to do it during the year, so to study which are the seasons which are richer in concentration of terpenes in air. The goal of this study was to determine the season and the weather conditions that promote the more a forest atmosphere with higher terpenes concentrations. To that, we chose the county of Sierra of Albarracín in the province of Teruel. And here you have a picture of the city of Albarracín. I recommend you to visit it. We chose 2 areas for study with conifers, with forest masses, and both within the same mountain chain. The difference between the 2 places was that in the area 1 there was more of Pinus sylvestris. Its distribution area is a huge part of the Euro-Siberian part that we can find in the Iberian Peninsula in the western areas. It was 1,500 meters high. As for the second area, Pinus pinaster is the species that we find the most its area is more reduced, and it is reduced, confined to the Western Mediterranean area. Once we studied both areas, once we had chosen both areas, we decided to focus on the sample calendar. To that we chose 9 days of sampling from March to November, one for each site. In each sampling area we showed we would analyze 7 air samples per day along a 2 kilometers forest trail, always sampling from 11 to 2 p.m. Here are 4 pictures in 4 months of the year, 4 moments of the year that could represent the 4 seasons of the year: winter, spring, summer, and fall. The sampling was very easy through a suction pump, an absorption pump. We push the air through this filter, a 10x sorbent filter, and the molecules would adhere to this filter. The flow was of 0.1 liter per minute, and this was through 50 minutes. We took an air sample and we could measure the relative humidity of air. We brought this air sampling to the lab and we could obtain then a chromatogram, one air sample chromatogram, each of them representing a molecule. We are going to focus on alpha-pinene, one of the molecules which are the most known in nature. We have the concentration of alpha-pinene evolution per milligrams per liter of air, and we can see that the measured concentration in each of the days of each month varies a lot. There are concentrations close to 0 and others which are close to 4 to -6 milligrams per liter of air. There is a vast difference vis-à-vis the sampling period. As for temperature and humidity, the temperature you can see it in orange. There is a variation of temperature according to the sample days. From 5 degrees to 30 degrees, the relative humidity of air represented in blue. We observe the variation throughout the year from 20% to humidities of 60%. With these two parameters, if we combine them, we can calculate a new parameter, which is the deficit, the vapor pressure deficit, as a dryer of this atmosphere. For the values of VPD, high VPD, they would indicate that the atmosphere has a high temperature and a low relative humidity. So we can find values of VPD close to 2 with temperatures above 25 degrees, and we can also find VPDs very close to 0 when the temperature is rather low and humidity around 60%. If we combine these climate factors with the alpha-pinene concentration, we can find some relations between the two parameters. We can say that concentrations of alpha-pinene in the atmospheres of the analyzed sites increased when temperature increases and decreases when the relative humidity of air increases. We found the same relationship in the two areas, in the two sites. If we analyze the concentration of alpha-pinene with the deficit of concentration of vapor, these correlations would indicate us that the most drying atmospheres with high VPD, higher temperatures and less relative humidities, we would obtain higher concentrations of alpha-pinene in the air. To compare both sites, we put the two correlations and we can see that the gradient of site 1 with Pinus sylvestris is sensibly higher than in the site 2. As what it tells us is that so that this forest reaches a concentration, determined concentration for site 2, we would need a VPD of about 2, whilst for the site 2 it would be around 3. So for site 2 the atmosphere would be drier to get this, to achieve this concentration of alpha-pinene. To conclude, let me remind you some tips around the report. The atmosphere terpenes concentration can depend on daily weather conditions. A drier atmosphere, that means a higher VPDs, higher temperatures and lower humidity. HR promotes a higher concentration of alpha-pinene in the air. In our case, in the Mediterranean area, summer season may favor higher concentrations of terpenes in the air with high temperatures. In drier climates, and different forest pines need different VPD values to reach similar air terpenes concentrations. And that was all. Thank you very much for your attention.